Hi everyone, this is Mrs. Snobeck. Today we are going to do Unit 8, Lesson 2, but before we get started, let's see if we remember the formulas from the last section. So take a second. Do you remember the formula for area of a parallelogram? The formula is area equals base times height. How about for a triangle? Area of a triangle. Area is base times height, divide by 2. Let's get started. Unit 8, Lesson 2. We're going to cover the areas of lots of different shapes today. We're going to cover trapezoids, rhombi, kites, circles, and sectors of circles. So there will be a lot of formulas, but you got this. Let's start with area of a trapezoid. So think back to Geometry A when you learned about trapezoids. Trapezoids have one set of parallel sides. So in this picture, you could see this top side is parallel to the bottom side. And so we have one set of parallel sides, so we have a trapezoid. To find the area of a trapezoid, you're going to add the bases. So let's just call this base 1 and this base 2. And then you're also going to need the height. And in a trapezoid, the height is perpendicular to the bases, just like it is in the parallelogram and the triangle, etc. Here's the formula. Area equals height times base 1 plus base 2 divided by 2. So I always just add the bases, multiply by the height, and then divide by 2. All right, one of Ella's isosceles trapezoid-shaped handbags is shown. Find the amount of material used to make the side shown. So we want to find the amount of material used for one side of this handbag, and it does say it is a trapezoid, and it says it's isosceles, which means this side also has to be 30 centimeters. So let's think of the formula. Formula for area of a trapezoid is height times base 1 plus base 2 divided by 2. Do we know the height? And the answer is no. It's this red dotted line, but we don't know what that is yet. And so we have to figure it out. So since it's an isosceles trapezoid, this distance down here is going to be 28. And so if we take 58 minus 28, we have 30 left. And we can see that if we divide 30 by 2, we get 15, which means this is going to be a length of 15, and this is also going to be a length of 15. So that all the way across the bottom of that purse or that handbag, we would have a distance of 58, but it would be broken up into 15, 28, and 15. Okay, so now the reason we did that is we can use this right triangle over here. I'm outlining it in green, and we can do Pythagorean theorem to find the height. So we can do 15 squared plus the height squared equals 30 squared. And we can solve that. 15 squared is 225. 30 squared is 900. Of course, subtract the 225. H squared ends up being 675. But then we have to take the square root. And h is going to be not a very nice number. It's 25.98. But the good news is we have our height. Do we know both of the bases? Yeah, one of the bases is 28. One of the bases is 58. We have everything we need now to find the area of the trapezoid. So we're going to do this. We're going to go area equals. Plug in your h, which is 25.98, parenthesis, 28 plus 58, and then divide everything by 2. You're going to type that into your calculator, and if you're typing it in correctly, go ahead and type it in. And if you type it in correctly, you're going to get 1,117.17. And remember, it's an area, so we're going to label it centimeters squared. Areas always have squared units. Let's try another one. Find the area of one side of the steel used to make the razor blade shown. So again, it looks to me like this is a trapezoid, that these sides would be parallel, and so the area formula would be height, parenthesis base 1 plus base 2, divide by 2. Do we know the height? The answer is no, we do not know the height yet. And so I noticed they have an angle there marked 68. I'm wondering, could we use this red triangle to somehow find the height? I'm thinking we can't do Pythagorean theorem because we only know one of the sides, but I'm wondering if we could do SOHCAHTOA. So the 1, if this is the right angle, the 1 would be the hypotenuse, and the other side that we're trying to find is the h, which would be, in this case, the opposite of angle 68. If you think about SOHCAHTOA, you're going to have to pick one of those, and you want the one with the O and the H. So you should pick SO. S stands for sine, so you're going to do sine 68 equals, and remember it has to be opposite over hypotenuse, so H over 1. Multiply both sides by 1, and really you're just going to have to type in sine 68 into your calculator, and when you do that, I believe you get 0.93. So the height is going to be 0.93 inches. Do we have both of the bases? Well, one base is 2 and the other base is 1.25. I think we have everything we need to solve this problem. So area equals the height, which is 0.93, times parenthesis 2 plus 1.25, which are the two bases, and then divide by 2. Type all of that into your calculator and you get approximately 1.5 inches squared. Let's do one more trapezoid. So Kevin designed a deck shaped like the trapezoid shown below. Find the area of the deck. All right, so it does say it's a trapezoid, so we have one set of parallel sides. The problem is we don't know one of the bases. One base I can see is 9, but the other base, I don't know what the other base is. However, do we know the height? Well, it's not really shown here, but I think we can assume that those two corners are 90 degrees. And so the height in this case is going to be the 4. That's the distance between the two parallel lines. All right, so let's try to find that other base. I'm thinking if I drop down a height over here, which I know is 4, I have a right triangle outlined in red. And if I just call this side x, I can do 4 squared plus x squared equals 5 squared. Or maybe you remember it is a Pythagorean triple. You might remember what that number is off the top of your head. But if not, do the Pythagorean theorem. So we get subtract your 16, x squared equals 9, and then take the square root, x equals 3. So the thing that we just figured out is down at the bottom here, this distance is 3, which means if the whole base was 9, this other side has to be 6, so that it adds up to 9 down here on the bottom. Well, if it's 6 on the bottom, it's going to be 6 on the top as well. Haha, we have our second base. The bottom is 9 and the top is 6. So now we have everything we need. We can do the area of the trapezoid. So remember, it's height times base 1 plus base 2, divide by 2. So let's fill in what we know. The height is 4. The bases are 9 and 6. And then divide by 2. This one I think we can do in our head. 9 plus 6 is 15. And 4 divided by 2 is 2. So 2 times 15 is 30, I think. 30 feet squared. Feel free to use your calculator to double check that, see if we got it right. Let's move on to the rhombus and the kite. So remember from geometry A that a rhombus is a quadrilateral with 4 congruent sides. So all 4 sides are the same length. And then also remember from geometry A, we studied kites and properties of kites. And the definition of a kite is that it has 2 pairs of consecutive congruent sides. So for instance, these 2 sides, they are consecutive, they're right next to each other, and they are congruent. That's 1 pair of consecutive congruent sides. And then down here we can have the second pair of consecutive congruent sides. Now, in order to calculate the areas of rhombi or kites, we use the diagonals. Now, the first diagonal is going to go from one vertex to its opposite vertex. So from here to here could be considered diagonal 1, the length of that dotted red line. The other diagonal will again connect opposite vertices, so it will start here and go as wide as that rhombus is. Same thing with kites. So let's say this is our first diagonal, and then here's our second diagonal. So it's the width from opposite vertices. So if we want to find the area of a rhombus or kite, here's our formula. We take diagonal 1 times diagonal 2 and divide by 2. I'll say it one more time. We take diagonal 1 times diagonal 2 and divide by 2. Let's try a couple. Number 4. So we can see we have a kite, and the two diagonals are marked as 8 meters and 15 meters. So to find the area, we take diagonal 1 times diagonal 2 and divide by 2. So in this case, it's just 8 times 15 and divide by 2, which is really 4 times 15, which is 60. And we have to label it meters squared. Let's try number 5. So number 5, we have a rhombus. One thing we know about a rhombus is the diagonals bisect each other. That does not happen for both diagonals in the kite, only one of them. But in the rhombus, both diagonals get bisected. And so, for instance, if one side of the diagonal is bisected by the other, they're both going to be 10 feet. And same here, this will also be 12 feet. So one diagonal is actually not 10, but 20. And the other diagonal is 12 plus 12, or 24. So to find the area, we would take diagonal 1 times diagonal 2, divide by 2. So if you think about that, I think we should wind up with 240 feet squared. Go ahead and check that with your calculator and see if you get that answer. Next, we have a working backwards problem. So here it says, find the value of x given the area of the kite is 92. I see some key words. I see area, I see kite. I know my formula is diagonal 1 times diagonal 2, divide by 2. Now plug in what we know. We know the area is 92. We know one of the diagonals is 22, but the other diagonal is just x. And then we're going to fill in the divide by 2. There's two ways to do this one. One is you could multiply both sides by 2, or you could do 22 divided by 2 and change that to 11. So either way, let's try it this way this time. Let's do 22 divided by 2 is 11. And then now we have to divide both sides by 11. So when we do that, it's not a great number. I think it is 8.36, and we would label that inches, not inches squared, because this is the length of a diagonal. Let's try number 7. Find the area of this rhombus. Okay, so first, I know the formula is diagonal 1 times diagonal 2, divide by 2 for a rhombus. It says RT, the distance from R to T is 24. So this right here is 24. So we know one of the diagonals is 24. And then they don't give us the other diagonal. They give us the measure of angle RST. So let's take a look here. RST is actually this big angle right here. That is 54. So somehow we have to use that 54-degree angle to find the other diagonal. Remember, this yellow diagonal we know, but we need to find this green diagonal. Well, in a rhombus, the diagonals meet at 90 degrees. They're perpendicular to each other. So this right here would be perpendicular. Also, the diagonals bisect the angles or the corners. And so that 54, if we cut 54 in half, we get 27. So what's going to happen is it's going to be 27 degrees here and here. That 54 gets bisected. Now, we know from R to T is 24, but diagonals bisect each other, and 24 divided by 2 is 12. And so this is 12, and this is 12. What if we try to find this distance? I'm going to put it in blue and call it X. I think we could do it using SOHCAHTOA. So if you think about this blue triangle, we have a 27-degree angle. The 12 is opposite of it, and the X is adjacent. So now you have to think about SOHCAHTOA, and you're going to pick one of these, the one with the O and the A. So you're going to pick TOA, and you're going to go tangent of 27 equals opposite over adjacent. Multiply by whatever's on the bottom of the fraction. So we're going to multiply by X this time. And then we also have to divide. It's X times tangent 27. So to undo the times, we have to divide. So we're going to divide by tangent 27 on both sides. And then finally we get X equals 12 divided by tangent 27, which we can now type into our calculator. And when we do that, I think we get 23.55. So what we found is halfway across that second diagonal. So what we have to do to get our second diagonal is we're going to take the 23.55 and we're going to double it, which is 47.1. And now we know that the length, let me erase some of this writing on the rhombus. We know the length of this diagonal, this part, was 23.55, and when we multiplied it by 2, then this was 47.1, which is our other diagonal. So here we go. Diagonal 1 is 24, diagonal 2 is 47.1, so multiply diagonals, divide by 2. Final answer, the area should be about 565.2. There aren't any units, so we'll just say units squared. Let's check out one more shape. The next shape we're going to do is circle. And some of you might remember halfway across a circle, it's called a radius. You can see it on the picture there. And to find the area of a circle, you take pi r squared. That might look familiar to you. You've probably done areas of circles before in other classes. So number 8, find the area of a circle with a diameter of 12. Well, if the diameter is 12, remember diameters go all the way across a circle. So the radius would be 6. It would be halfway across. So the area is going to be pi 6 squared. Pi 6 squared, if you type it in your calculator, should be 113.1, and then there aren't any labels, so we'll just say units squared. Here we have a working backwards question, number 9. Find the radius of a circle with an area of 95 centimeters squared. So keywords, I see area, I see circle. That tells me I'm probably going to use A equals pi r squared. Plug in what you know. Well, you know the area is 95, so that's going to go in for the A. Pi stays pi, and we don't know the radius. So I guess we'll just leave that r. Now we have to work backwards and try to get r by itself. So to get r by itself, I think I would start with trying to divide by pi. So then we would have only r squared over there. When we do that, we get approximately 30.24. And then on the right side, we still have r squared. But we don't want r squared, we want just plain r. So we'll take square root, and the radius ends up being approximately 5.5 centimeters. And let's try number 10. Find the diameter of a circle with an area of 196 pi yards squared. So read the question carefully. Look for key words. I see the word circle. I see the word area. That's probably going to tell me what formula to use. I always like to write down my formula. So area equals pi r squared. Now at least I know what I'm dealing with. And then try to figure out what can I plug in. Well, it says the area is 196 pi yards squared. So 196 pi goes in for the A, and that equals pi, and then we don't know r, so we'll just leave it r squared. We want to try to solve this for the diameter. So I'm thinking if I can find the radius, then I can just double it to get the diameter. So let's try to find the radius. Divide by pi, something kind of cool happens. The pi cancels on both sides. So now we have 196 equals r squared. This is good. We take the square root and we actually get a nice number. The radius is 14. But remember, they wanted diameter, and so your diameter is going to be 14 times 2, which is 28, and our label is yards. Last but not least, today we're going to study sectors of circles and how to find the area. Remember, a sector is like a piece of pie. You can see it's shaded in this top picture here in red. That is a sector of a circle. And to find the area of a sector, we're going to take x over 360 pi r squared. So it's kind of like a circle. Pi r squared would be the whole circle, but we're just going to take a certain number of degrees out of 360. So let's go down to number 11 and see if we can find the area of the shaded sector. So again, I know the formula is x over 360 pi r squared because it's a sector. The x is the number of degrees of the sector. So in this case, it is 148 out of 360 pi, and then I can see the radius is 6, so 6 squared. Now I'm probably going to have to put some parentheses around the 148 divided by 360 when I type this in my calculator. Go ahead and try typing yours in. And if you do it correctly, you should get 46.5 meters squared. Last but not least, number 12. They're trying to trick you here. You have to remember you're finding the area of the shaded sector. So the shaded sector is actually going to have degrees all the way around here, not the 65. So I think out of 360, if we subtract the 65, we wind up with 295 left. I think 295 is the angle of the sector. It's everything except the 65. So here we go. We're going to say 295 out of 360 times pi, and then I need the radius, which I can see right here is 11 squared. I type it in my calculator, probably putting parentheses around the 295 divided by 360, and my final answer is 311.5 approximately, and it's inches squared. Cool, that was a lot of information. We did trapezoids, rhombi, kites, circles, and sectors. That's a lot of formulas, but just look back at your notes. That wraps up Unit 8, Lesson 2. So now please try the practice. If you get stuck, let me know. Have a great day.